गुड मॉर्निंग एवरीवन। कल हम लोगों ने पढ़ा था द पोजीशन स्पेस रिप्रेजेंटेशन एंड मोमेंटम स्पेस रिप्रेजेंटेशन। कल यूट्यूब क्लास में हम लोगों ने पोजीशन स्पेस रिप्रेजेंटेशन पढ़ा, मतलब हाउ टू डिस्क्राइब एन हिल्बर्ट स्पेस इन द बेसिस ऑफ पोजीशन ऑपरेटर, जहां पे हम लोगों ने पहली बार वेव फंक्शन का कॉन्सेप्ट इंट्रोड्यूस किया कि वेव फंक्शन क्वांटम मैकेनिक्स में क्या होता है। दैट इज नथिंग बट द प्रोजेक्शन ऑफ द स्टेट वेक्टर अपॉन द आइगन वेक्टर ऑफ पोजीशन ऑपरेटर। फिर उसके बाद हम लोगों ने देखा कि उसका फिजिकल इंटरप्रिटेशन हम लोग क्या दे सकते हैं। आफ्टर दैट वी केम टू मोमेंटम रिप्रेजेंटेशन। फिर मोमेंटम रिप्रेजेंटेशन में हम लोगों ने देखा मोमेंटम वेव फंक्शन क्या होता है। दैट इज नथिंग बट द प्रोजेक्शन ऑफ द सेम स्टेट वेक्टर अपॉन द आइगन वेक्टर ऑफ मोमेंटम ऑपरेटर। दूसरी बात हम लोगों ने देखा कि एक पार्टिकल का भी एक पर्टिकुलर पोजीशन नहीं हो सकता इन क्वांटम मैकेनिक्स। सिमिलरली एक पार्टिकल का भी एक पर्टिकुलर मोमेंटम नहीं हो सकता, क्योंकि अगर पार्टिकल का एक पर्टिकुलर पोजीशन है, सो पार्टिकल हैज टू बी on the eigenvector corresponding to that eigenvalue. Suppose उसका अगर position है x equal to 6, so its eigenvector has to be x equals to 6 ket. But ये जो eigenvector है of the position operator corresponding to the eigenvalue 6, that is not normalizable. So eigenvectors of position operator are not normalizable, so a particle cannot be in a state physically which is not normalizable. So therefore a particle cannot have a particular position in quantum mechanics, it cannot have a particular momentum in quantum mechanics, but of course a certain range the particle can always be determined. तुम हमेशा particle को एक certain range में determine कर सकते हो, but एक particular value of position and momentum मिलना थोड़ा मुश्किल है। उसके बाद आज हम लोग देखेंगे ये जो पोजीशन और मोमेंटम का जो कोऑर्डिनेट सिस्टम रिप्रेजेंटेशन है हिल्बर्ट स्पेस का। तो हिल्बर्ट स्पेस को पोजीशन ऑपरेटर का आइगन वेक्टर्स में रिप्रेजेंट किया, तुमने हिल्बर्ट स्पेस को मोमेंटम ऑपरेटर के आइगन वेक्टर्स में रिप्रेजेंट किया। तो इसका जो रिप्रेजेंटेशन है उस चीज को हम लोग थोड़ा सा कैसे कनेक्ट करें वो हम लोग देखेंगे। सो कनेक्टिंग द पोजीशन एंड मोमेंटम रिप्रेजेंटेशन आज के चैप्टर आज का टॉपिक का नाम है कनेक्टिंग the position and momentum representation. Position and momentum representation, how will you connect them? तो जरा यहाँ पे देखिए, कैसे कनेक्ट करोगे आप लोग। बोला गया है कि देखो, we know that r के साथ psi, let psi be any arbitrary ket, तो let psi be any arbitrary ket belonging to the Hilbert space. अगर ये सिनेरियो है तो भाई साहब हम क्या लिख सकते हैं, साई को हम लोग लिख सकते हैं आर साई को हम लोग लिख सकते हैं आर वेक्टर आई कैप साई, जहां पे आई कैप को हम लोग मोमेंटम ऑपरेटर के जो कंप्लीटनेस रिलेशन है मोमेंटम आइगन वेक्टर्स के उससे लिखेंगे। वी नो दैट आइगन वेक्टर्स ऑफ मोमेंटम ऑपरेटर आर complete from a complete basis, so therefore I can always write it integration all space p d cube p, that's all I can write over the all space then psi। अब यहां पे देखो r के साथ p आ जाएगा, psi के साथ p आ जाएगा, राइट, फिर डी क्यू पी हो जाएगा। तो मतलब इस चीज को मैं लिख सकता हूं इंटीग्रेशन r के साथ p फिर यहाँ पे psi के साथ p, सॉरी p इस तरफ psi इस तरफ, तो p विल बी ओवर हियर, psi विल बी हियर, तो psi के साथ p, and then we can talk about d cube p. d cube p. d cube p is the volume in the p space, momentum space. अच्छा, psi के साथ p का इनर प्रोडक्ट तुम्हें psi of p देगा, तो definitely we can write it as integration psi p of p vector into r comma p into dq bar, सॉरी dq p, ये चीज है जहां पे r psi हम लोग इसे क्या लिखेंगे, psi of r. तो psi r of, यहाँ पे एक चीज मुझे लिखना था, that is psi r of r. The wave function is basically can be written as r के साथ psi का inner product. तो psi of r, so psi r of r is equals to psi r of r vector is basically the wave function in position space is r के साथ psi का inner product, projection of psi over r, that is r I cap psi, that can be written as r this thing into psi I cap. I can write it like this way by the completeness condition of the eigenvectors of the momentum operator, then rp and then p psi is psi of p, then rp dq of p. That's all. Similarly I can also write psi p of p, psi p of p is actually your p के साथ psi का inner product, that is actually equals to p I cap psi which I can write it over here as p को p लिखो, I cap के लिए मैं लिखूंगा completeness condition for the eigenvectors of position operator, that is r dq bar, r dq bar. So if it's done, then this is your psi. अब अगर तुम करोगे यहां पे p के साथ r के साथ psi, इंटीग्रेशन p के साथ r देन r के साथ psi then d cube r. Now you just carry on. R के साथ psi का inner product आता है तुम्हारा psi r of r, which is the position space wave function. So psi r of r vector, position space wave functions, then p के साथ r का inner product, p r दोनों के बीच में inner product, then dq bar, इंटीग्रेशन ओवर ऑल स्पेस. ये मैं लिख सकता हूं. अब फूरियर ट्रांसफॉर्म बोल के एक चीज होता है जो तुम लोगों को मैं बता सकता हूं, दैट फूरियर ट्रांसफॉर्म एनी फंक्शन बिटवीन टू वेरिएबल्स. कैसे, जरा मैं तुम्हें दिखा दूं. जरा देखो, फूरियर ट्रांसफॉर्म, FOURIER, फूरियर ट्रांसफॉर्म ऑफ एनी फंक्शन जो कि फंक्शन ऑफ आर है, आर से मैं पी में ट्रांसफॉर्म कराना चाहता हूं, तो एफ ऑफ आर कैन बी रिटन एज 1 divided by, I mean, just give me a moment. There is a much better way to write it down. Fourier transformation में just hang on for a moment. Okay, so just let's, good morning Nafia. Let's just represent the Fourier transformation this way. In 3D, अगर मैं 3D में Fourier transformation दिखाना चाहूँ तो 1/√2 pi h cut to the power of 3/2 integration all space, then g of p, so p से r में ट्रांसफॉर्मेशन हो रहा है, g of p e to the power of I t r by h cut I into p dot r by h cut into d cube of r, सॉरी d cube of p. ये है तुम्हारा फूरियर ट्रांसफॉर्मेशन फॉर्मूला इन 3D. इस फॉर्मूला के साथ यहाँ पे इसका तुम देख सकते हो इक्वेशन 1 का. ये अगर मान ले मैं बोलूँ इक्वेशन 1 है मेरा, ये मेरा इक्वेशन 2 है, तो इक्वेशन 1 में हम देख पा रहे हैं कि साई आर ऑफ आर, अ फंक्शन ऑफ आर that is equal to a different function of p rp d cube p. तो इसके साथ अगर मैं इसका कंपैरिजन करूं, this is the Fourier transformation equation, that is equation 3. So comparing equation 1 and 3, हमें क्या मिल रहा है बेटा? Comparing इक्वेशन 1 एंड 3, अगर 1 के साथ इक्वेशन 3 का मैं कंपेयर कर रहा हूं तो ये फूरियर ट्रांसफॉर्मेशन इक्वेशन है. ये तुम्हारा साई आर ऑफ आर है जो कि एक फंक्शन ऑफ आर है, दैट इज एक्चुअली इक्वल टू साई पी ऑफ पी आर पी डी क्यूब पी. तो इसके साथ इसका अगर मैं कंपैरिजन कर रहा हूं तो मुझे क्या मिल जाएगा बेटा? साई पी ऑफ पी आर पी डी क्यूब पी. तो मुझे मिलेगा, इधर तो फंक्शन ऑफ आर है, फंक्शन ऑफ आर है, यहाँ फंक्शन ऑफ p है, डी क्यूब p है, फंक्शन ऑफ p है, डी क्यूब p है. बाकी जो टर्म है दैट शुड बी इक्वल्स टू माय r p का इनर प्रोडक्ट. therefore I can write r और p का जो इनर प्रोडक्ट है दैट इज इक्वल टू माय 1 divided by 2 pi h cut to the power of 3/2 into 2 pi h cut to the power of 3/2 into e to the power of I into p dot r, e to the power of I इंटू पी डॉट आर। ये एक बहुत ही इंपॉर्टेंट सा रिलेशन है जो मुझे अभी के अभी मुझे मिला, जो मैंने प्रूफ किया, डिवाइडेड बाई एच कार्ड। बहुत ही इंपॉर्टेंट सा रिलेशन है जो अभी मुझे मिला, मैंने जैसे प्रूफ किया, बड़ा ही इंपॉर्टेंट सा रिलेशन है। तो ये तुम्हारा फूरियर ट्रांसफॉर्मेशन है। अच्छा, इनवर्स फूरियर ट्रांसफॉर्मेशन भी कर सकते हो, या अगर आरपी तुम्हें मिल गया, तुम इनवर्स फूरियर ट्रांसफॉर्मेशन भी कर सकते हो। इनवर्स फूरियर ट्रांसफॉर्मेशन फॉर्मूला से तुम इसका निकाल सकते हो, या यहां से आरपी मिल गया तो पीआर तुम निकाल सकते हो। देयरफॉर पीआर क्या होगा? कॉम्प्लेक्स कॉन्जुगेट ऑफ दिस आरपी का कॉम्प्लेक्स कॉन्जुगेट, दैट इज एक्चुअली इक्वल टू तुम्हारे इस चीज से कॉम्प्लेक्स कॉन्जुगेट, दैट इज योर e to the power of minus IPR by h cut e to the power of negative of I p dot r by h cut whole divided by 2 pi h cut to the power of 3 by 2। इसको हम लोग लिख सकते हैं, दूसरे कलर से लिखते हैं तो बेहतर लगेगा। कंपेरिजन दिस r के साथ p का जो इनर प्रोडक्ट है वो क्या आ जाएगा बेटा? r के साथ p का इनर प्रोडक्ट आ जाएगा तुम्हारा e to the power of I p dot r by h cut I p dot r by h cut divided by 2 pi h cut to the power of 3 by 2। e to the power of I p dot r by h cut divided by 2 pi h cut to the power of 3 by 2। So these are the two formulas which are very very important formula। इस formula का मैं नाम देता हूँ formula number 4, इस formula का मैं नाम देता हूँ formula number 5। बड़ा ही important formula है, बड़ा ही important formula है। ठीक है, अब ये चीज हमें जरूरत पड़ेगी, ये चीज हमें जरूरत पड़ेगी। और एक चीज मैं बता दूं, अगर पोजीशन वेव फंक्शन दिया गया है तो मोमेंटम वेव फंक्शन, अगर मोमेंटम वेव फंक्शन दिया गया है तो पोजीशन वेव फंक्शन लिखने का फॉर्मूला यहां से आ जाएगा। मोमेंटम वेव फंक्शन दिया गया है तो यहाँ पे बस आर डॉट पी आर पी और पी आर का वैल्यू पुट करो। Using 4 and 5 we can write 1 and 2 as, using 4 and 5 we can restate 1 and 2 as, अगर हमारे पास दिया गया है सर जी पोजीशन वेव फंक्शन psi r of r vector, that will be actually equals to 1 by root over of 2 pi h cut to the power of 3 by 2, 1 by 2 pi h cut to the power of 3 by 2 integration all space। फिर क्या आएगा? r है तो psi p of p चाहिए, मोमेंटम स्पेस वेव फंक्शन चाहिए, e to the power of I into p dot r by h cut p dot r by h cut d cube p, that's all। Then I can write psi p of p, मोमेंटम स्पेस वेव फंक्शन कैसे निकालोगे अगर पोजीशन स्पेस वेव फंक्शन दिया गया है तो 1 by 2 pi h cut to the power of 3 by 2 is basically equals to integration all space। यहां पे तुम लिखोगे e to the power of psi of r vector, psi r of r vector, then e to the power of माइनस आई पी डॉट आर बाई एच कट डी क्यूब ऑफ आर, दैट्स ऑल। अब ये जो है ये तुम्हारा 3D में है, अगर 1D में यही इक्वेशन लिखना हो तो कैसे लिखोगे? दिस इज द इक्वेशन इन 3D, ये 3D इक्वेशन है। अगर 1D में लिखना है तो कैसे लिखोगे? सर जी 1D में लिखना हो तो हम लोग लिखेंगे साई आर ऑफ एक्स इज इक्वल्स टू 1 डिवाइडेड बाई रूट ओवर ऑफ 2 पाई एच कट इंटीग्रेशन माइनस इन्फिनिटी टू प्लस इन्फिनिटी psi p of px e to the power of minus I नहीं plus I px into x by h cut dx, sorry dpx। और अगर तुम्हें psi p of px चाहिए तो उसमें तुम लिखना 1 डिवाइडेड बाई रूट ओवर ऑफ 2 पाई एच कट इंटीग्रेशन माइनस इन्फिनिटी टू प्लस इन्फिनिटी साई आर ऑफ एक्स e to the power of minus I px into x by h cut dx. That's the equation in 1D. 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 It's a very important stuff. You don't have to worry about anything. It's done here. That's the equation. These two are the equation in 1D. 1D में अगर तुम्हें करना है चेंज तो तुम इस इक्वेशंस को फॉलो करोगे। 1 by root over 2 page cut, 1 by root over 2 page cut, integration minus infinity to plus infinity, minus infinity to plus infinity, यहाँ पे psi p of px, यहाँ पे psi r of x, e to the power of I px x by h cut, e to the power of minus I px x by h cut, d cube px d cube x, done। अच्छा, transformation does not affect the normalization. So if psi p is normalized, psi r will also be normalized. If psi r is normalized, psi p will be normalized. ठीक है? The transformation never affect the normalization. यहाँ पे मैं लिख देता हूं, remember FOURIER, Fourier transformation never affect the normalization of the function. Full stop. Therefore, if psi p is normalized, after transformation, psi r will also be normalized. Therefore, if psi p of p is normalized, after transformation, psi r of r will also be normalized. And vice versa. चलो, आई होप दिस इज डन, ऑल ऑफ यू हैव गॉट इट। बहुत ही बढ़िया सवाल है कि पहले अगर वेव फंक्शन तुम्हारा नॉर्मलाइज्ड है तो ट्रांसमिशन के बाद भी नॉर्मलाइज रहेगा, और अगर पहले वेव फंक्शन नॉर्मलाइज नहीं है तो ट्रांसमिशन के बाद भी नॉर्मलाइज नहीं रहेगा। तुम अगर एक बार नॉर्मलाइज कर लिए तो तुम्हारा काम खत्म। बस एक बार वेव फंक्शन नॉर्मलाइज कर लो, डन। प्रूफ कैसे करोगे कि ट्रांसफॉर्मेशन डज नॉट अफेक्ट द नॉर्मलाइजेशन? हाउ विल यू प्रूव दैट द ट्रांसफॉर्मेशन डज नॉट अफेक्ट द नॉर्मलाइजेशन? वो हम फटाक से प्रूफ कर देंगे, वो प्रूफ करना बहुत बड़ी बात नहीं है। बट इफ यू पीपल वांट द प्रूफ, आई कैन प्रूव इट। इफ यू डोंट वांट द प्रूफ, let's prove that transformation does not affect the normalization. Or we can just simply let psi is 1 integration psi p star of p psi p of p. Of course, don't forget to put the vector sign. Then d cube p all space. That is actually equals to integration d cube p. Well, just keep psi star of p unchanged. Psi star of p unchanged. And I can write psi of p as this. Psi of p, I can write this thing. 1 by 2 pi h to the power of 3 by 2 psi of r e to the power minus I p dot r by h d cube r. 1 divided by 2 pi h to the power of 3 by 2 integration psi r of r e to the power of minus p dot r by h cut d cube r. Minus I into p dot r. Psi r of r e to the power of minus I into p dot r minus I into p dot r by h cut d cube r. That's all. This is it. And then finally d cube p. I can write this in the form like integration. I'm bringing psi of r outside, d cube r outside, and d cube p inside. So I'm writing it as like psi r of r, putting this integration inside. So 1 by root over of 1 by 2 pi h cut to the power of 3 by 2 integration psi p star of p e to the power of minus ip dot r by h cut. I'll do it now in terms of d cube p. Then I'll close the bracket. and I'll put dq bar. Just have a look. This formula, psi star of p to the power of minus it dot, this formula is actually represents psi star of r. This one represents psi star of r, so psi r of r. This one represents psi star r of r into dq bar. All space. We should write all space everywhere. Fine. So this one is basically equals to, just because I said initially psi of r is normalized, so this will also remain normalized. That will be actually equals to 1. And this is known as Parseval's theorem. This result is known as PARACVAL, Parseval's theorem. This result is known as Parseval's theorem. After that, momentum operator in position representation. How would you write down momentum operator in position representation? That's another important thing. Let me tell you this. The momentum operator in position representation. Momentum operator in position representation. Done. How would you represent it? Let's find out RP psi. R, momentum operator P, of course it's in vector, psi. Let's find out this. We can write it as integration R. Okay. P can be written as integration. Okay. I can just write R. P can be written as P. Well, then we can just introduce two terms. I cap, which is basically your integration PPDP, integration P dqp. Done. This is your I. Then psi. I can write it. So have a look. I can write this is your I cap. So pi, this I can write. Now on the next line I can just mention it as R vector P. This is an operator. This one is an operator. This one is just a ket vector. This one is an operator. And then we have this P psi. Then I have dqp. Then I have this integration. Good. Now, I know this is an eigenvector of the momentum operator. So p cap operates on this, gives me p into ket p. So it will become actually equals to p as a scalar, p as a just simply a normal, not state vector, simply as a normal vector. Integration, not a Hilbert space vector. It's just a usual vector which you learn in 11, 12. P, this is RP, R and P, R and P. Then this is P, this is RP. Here is your P psi. d cube p. P psi is your psi p of p d cube p. Done. Now we can write it like this. Now rp we know, right? We know this. rp we know. Psi of p is something we already know. D cube p. Psi of p d cube p is done. rp we know. rp. So is there any help for this that we can use? See, r comma p, if you want to write, you can write r comma p as r inner product p. R inner product p is with the power of I p dot r by h cut 2 pi h cut to the power of 3 by 2. So p vector e to the power of I p dot r by h cut divided by 2 pi h cut to the power of 3 by 2. To the power of 3 by 2. Psi p of p d cube p. ये हो गया है. And after that, इस चीज को हमें कुछ लिखना है. I e to the power of I p dot r by h cut. Okay, p to the power of I p dot r by h cut. This thing psi p of p. I can write this thing as minus I h cross del e to the power of I p dot r by h cut by 2 pi h cut to the power of 3 by 2. Okay, into psi of p d cube p. Integration that I can show you in 1D, not in 3D. I can prove this in 1D. Minus I h cut partial differentiation of x, that is your del, and I'm doing it for e to the power of I px x by h cut e to the power of I px x divided by h cut divided by root over of 2 pi h cut, root over of 2 pi h cut. Can you prove what this will come? I have to differentiate this with respect to x, right? So minus I h cut by root over of 2 pi h cut will be there. If I do the differentiation of this with respect to x, it will give me e to the power of I px into x by h cut, and then इस चीज का differentiation होगा I px by h cut. I px by h cut. You see h cut कट जाएगा. I into I is I square, that is minus 1. वो minus 1 is minus 1 आ जाएगा. तो simply px e to the power of I px into x by h cut divided by root over of 2 pi h cut. तो इस फॉर्मूला से हम लोग देखो px into the power of I px x by h cut root over 2 pi h cut, इसको हम लोग minus I h cut partial differentiation of x ऐसे लिख सकते हैं. सिमिलरली यहाँ पे भी हमारा था p into the power of I p dot r by h cut 2 pi h cut to the power of 3 by 2, इसको लिख सकते हैं minus I h plus del to the power of I p dot r by h cut 2 pi h cut to the power of 3 by 2. That's all. On the very next line I can write it. Right, I can take this is differentiation with respect to x, this is with respect to spatial coordinates, this is integration with respect to momentum coordinates. So very well I can take it also as the integration. Minus I h plus del minus I h cross del, this thing is your rp, and of course again this thing is your psi p of p is can be written as your p psi d cube p. Just have a look, integration pp d cube p is your I, this can be written as r integration p d cube p, here psi, this one is I, so r psi minus I h cross del r psi, which is your psi r of r, minus I h cross del psi r of r vector, which implies that momentum operator in position representation is 3D momentum operator in position representation is negative of IH cross into del R, that is minus IH cross partial differentiation with respect to x into I cap plus partial differentiation with respect to y j cap plus partial differentiation with respect to, with respect to z into k cap. That's what your momentum operator is. In one dimension, if you ask me, I can say it's a simple note. In 1D, if you ask me, then px cap, py cap, pz cap will become equals to negative of IH cut, negative of IH cut, negative of IH cut, partial differentiation with respect to x, partial differentiation with respect to y, partial differentiation with respect to z. With respect to z. Similarly, you can, so this is the position operator in your momentum operator in your position representation. You can prove by yourself that px, py, py, pz, px, commutator are all 0. What is x, px? X, px, can you determine it for me? Px cap. So all you have to do is just take a trial function f of x. Let's take a trial function f. So you can write this as x px minus pxx into f. Tell me, if I write it in position representation, what this will become? It's x into minus IH cross partial differentiation with respect to x minus negative of IH cross partial differentiation with respect to x into, there is an f outside. So the first term would become minus I h cut x partial differentiation of f with respect to x minus minus plus h cut I h cut actually. Second term is your partial differentiation of x f Differentiate with respect to x keeping f unchanged plus differentiate with respect to do the differentiation of f keeping x unchanged. So this will become equals to this will get cancelled out. Minus I h cut x f with respect to x plus I h cut x f with respect to x then plus I h cut f. So you see this will get cancelled out. You're gonna get I h cut f. Cancelling f from both sides, I'm gonna get x comma px is your I h cut. Proved. This is proved. Everyone can see. I'm just turning off. You all can see this, right? You all can see this expression. Similarly, if you want me to prove y comma px will be 0, z comma px will be 0. Again, similarly, in the similar manner, we can write x comma px. So therefore, x px, y px, z px. This one is I h cut. This one is 0. This one is 0. Similarly, x py, y py, z py. This is I h cut 0, 0. Again, xpz, ypz, zpz. So this thing is I h cut, this thing is 0, this thing is 0. So this is it. Now again, if you ask me the moment position operator in momentum representation, that I can also show you. That I can also show you the position operator in momentum representation. Again, if there is something called like this thing, px, comma function of x. I might ask you to calculate this thing. Px is basically an operator, function of x cap is an operator. How will you do this? So it will be better if you take a trial function g, then it will become equals to pxf minus fpx with the trial function g. Good. So minus I h cross partial differentiation with respect to x. This is function of x. G will get multiplied. Then there f will come outside. Px is minus I h cross partial differentiation with respect to x. G will be here. Do the differentiation minus I h cross. if you do it, f with respect to x, g into f with respect to x plus f into g with respect to x then minus plus ih cut f into g with respect to x. You can see g with respect to x, f g with respect to x plus ih cut minus h will get cancelled out. You finally get minus ih cut g into f with respect to x. That's what I'm getting. G into f with respect to x. This will be written as like f with respect to x, g on this side. Yes, now it's done. This can be done. So minus ih cut f with respect to x, and here you have your g. G on both sides is extra, you can cancel out. So px comma function of operator x will always provide you minus ih cut partial differentiation of x with respect to x. Or just f is only a function of x. So yeah, you can write it like this. No issues. Done. So this is it. There is no extra calculation. And later on in the masterclass, we will talk about how you can write the momentum in position operator in momentum representation. In next lecture, we're going to be talking about how to write the position operator in momentum representation. In the next lecture, we're going to be talking about how to write down the position operator in momentum representation. Write down the position operator in momentum representation. Okay, chalo. Thank you very much. If you need this lecture PDF, you can definitely follow my Telegram channel, which is Sourav Sir Testbook. I will upload this PDF over there. And apart from that, the booster course, you people can always register to the booster course, which contains all the theory lectures in the recorded format. Apart from that, lots of mock tests are there in the live classes. We are solving the PYQs, and the PhD mentorship program is there, and lots of PYQ books will be offered to you. So it's the best course that you can carry for the revision purpose. And of course, at this point of time when you don't have much time to go through all the chapter by yourself. So for the revision or understanding of any portions, if you need, you can definitely go for the booster course. How will you enroll for the booster course? I can show you. All you have to do is to let me just show you. All you have to do is to just go to hang on, Google Chrome and write down CSIR NET Supercoaching. So just can you see? No. Hang on, let me just check if there is an issue. Yes. Now I hope all of you can see. You can just go there. You can write down CSIR NET Supercoaching. The first hyperlink will appear. You will just click on that first hyperlink. After that, you just scroll down a little bit. and you will get that CSIR NET Physical Science Booster Course December. Click on it. Just click on buy now, enter your phone number and click on continue. You will get the proceed to payment. Click on that. You will get use the promo code. So once you use promo code, the price will be reduced enormously and you can buy that course on this price. तो प्लीज बिल्कुल मत भूलना प्रोमो कोड यूज करने में, क्योंकि अगर नहीं यूज करो तो ज्यादा पैसे देके खरीदना पड़ेगा. प्रोमो कोड लगाओगे तो मैक्सिमम डिस्काउंट पॉसिबल है उस डिस्काउंट में मिल जाएगा. एंड द प्रोमो कोड इज माय नेम SOURAV सॉरी. बाकी कोई भी डाउट है आप लोग यूट्यूब में कमेंट सेक्शन में बता सकते हो, टेलीग्राम में हम लोग को बता सकते हो. Apart from that, if there is any doubt, any issues, feel free to reach us. Thank you very much. मिलते हैं next session में.